Question number 11, 12 and 13 are actually based on this particular given paragraph here. It is a biconcave lens of mu is equal to 1.5, R1 to be equal to 20 centimeter, R2 is 30 centimeter, is placed in a liquid of refractive index mu m. An object is placed at a distance of 32 centimeter. Then we need to find how the nature of the images would be and its distance, whether it is magnified or diminished. Well, we shall start with the calculation of the equivalent focal length, or simply from the lens maker formula itself. I would say 1 by V minus 1 by U must be equal to mu minus mu m divided by mu m 1 by R1 minus 1 by R2. Putting these values, I'll be getting 1 by V minus 1 by U. It would be equal to mu is how much? It is 1.5 and mu m is 1.2. So it is 0.3 or 3 by 10. Here it is 12 and 10. R1 is minus of 20 and it is 30. So it will be minus 1 by 20 minus 1 by 30. This one will cancel out. It is 4 here. So 1 by V minus 1 by U equal to 1 by 4. I would take 1 by 10 as common. This is minus 1 by 2 plus 1 by 3. This is 5 divided by 6. So 5, 2 here and minus 1 by 48. So effective focal length of the system is minus 48. Now placing the value of U, I'll be getting 1 by V, U to be how much? Minus of 32. It is 1 by 32 here minus 1 by 48, or 1 by V is equal to minus 1 by 48 minus 1 by 32. On calculation, I'll be getting this answer as V to be equal to minus 19.2. What it means? It is behaving like a concave lens here. The focal length is minus of 48. Object distance is 32 here and the image is forming at this point. So this is the way it will be formed. So effectively I would say image is virtual, it is diminished, and the image distance we found it to be minus 19.2. So for question number 11, option B and C are the correct answers. Now let's proceed to question number 12. Here in question number 12, if mu refractive index of medium is 1.8, yet again I'll calculate in the similar way. It is 1 by V minus 1 by U is equal to mu minus mu m. This time it is 3 by 10 with negative sign, divide by mu m. It is 18 and 10 here, and this part is minus 1 by 20 minus 1 by 30. Okay, so 1 by V minus 1 by U, this 10 will cancel out. Here it is 6. These two negative sign and here the negative sign, it will become 1 by 6. This is 1 by 10. 1 by 2 plus 1 by 3, it is 5 divided by 6. So 1 by V minus 1 by U, it is coming out to be 1 by 72. So effective focal length is how much? 72 in positive. That means it is behaving now as a convex lens. Okay, so putting the value of U to be equal to minus 32 here, I'll be getting 1 by V is equal to 1 by 72 minus 1 by 32. This value for V is coming out to be minus 57.6 centimeter. It means this is the lens this time. Focal length is 72 here. Object is placed at 32 and the image is formed at how much? Minus 57.6 somewhere here around. That means image distance is 57.6. Image is virtual and image is enlarged. So for question number 12, option A, C and D are the correct answers. Now let's proceed to question number 13. In question number 13, if mu m is 1 and surface of radius R2 is silvered, that means here this medium is having the refractive index of 1 and this surface is being silvered. So first we need to calculate the effective power of the system. So I would say the focal length of the lens would be how much? It would be 1 by f of L. It is mu minus 1. It is how much? 1.5 minus 1. It will come out to be 1 by 2. And this one is minus of 1 by 20 minus 1 by 30. Okay. Or 1 by FL, it is minus of 1 by 2, 1 by 10 into 5 here and 6. So it is minus 1 by 24. So focal length here is how much? Minus 24 centimeter. And the focal length of mirror, it will be positive because this surface is being silvered. So this is now a convex mirror. So it will come out to be plus 15 centimeter. So effectively, whole of this system will now behave like a mirror. So effective power of the system, or in fact mirror, would be taken as P is equal to twice of the power of lens plus power of mirror. So it is minus of 2 divided by 24, and the power of mirror is reciprocal of the focal length of the mirror with negative sign. It is minus 1 by 15. So in SI unit, we need to multiply it by 100. So we'll be getting this calculation as minus 100 into 3 divided by 20. Okay. Now, effective focal length of whole of the system. This is the effective power. So focal length will be how much? It is reciprocal of this part with the negative sign. So focal length, we are getting this one as how much? It was 20 divided by 3 into 100, negative sign, and this negative sign will become positive, and in centimeter it will be this much. So it is 20 by 3 is the focal length. So effectively this one is now behaving like a convex mirror with the focal length of 20 by 3. Now we need to find the image distance. It will be 1 by V plus 1 by U is equal to 1 by F. So it is 3 by 20 here, or 1 by V would come out to be 3 by 20 minus 1 by U. U was how much? It was minus 32. So it is 32. So on calculation, we'll be getting this value of V somewhat close to 5.5 centimeter. So this is the effective system now. Object was placed somewhere here around, and after reflection, the image will be formed somewhere here around at the distance of how much? 5.5 centimeters. So image is virtual, image is diminished, and image distance is how much? 5.5 centimeter is the correct answer. Option B, C and D are the correct answers for question number 13. Now let's proceed to question number 14. Here we are provided a paragraph based on which question number 14 and 15 are there. In a circuit arrangement shown, parallel plate air capacitors are connected to a battery. A dielectric slab is inserted in one of these capacitors. Now in question number 14, if the slab is inserted in capacitor C2, then? Well, we know that in a series combination with the applied potential difference, voltage drop will be higher for the capacitor having the lower capacitance. Got it? If C is higher, voltage drop will be on the lower side. Okay, based on that part itself. Earlier, let's say the potential difference here was E1, and across these 2 points it is E2. Now, if the slab is inserted in capacitor C2 on this part, then whole of the capacitance of this system will increase, or I would say the potential difference here, it will decrease. That means here the potential difference has increased. So the charge on C1, it has increased. The charge on C1 has increased. It means here the total charge on the system has also increased. That means on this part now, what we found, the potential drop across C3 has actually decreased. So I would say charge on C3 has actually decreased. That means here the charge has decreased and overall the total charge has increased. It simply means that charge on C2 must have increased. C2 must have increased. So we got the answer here. So charge on capacitor C1 increases, charge on capacitor C3, this is the wrong option. Charge on capacitor C2 increases, that is correct, and charge on capacitor C3 decreases. So for question number 14, option A, C and D are the correct answers. Now let's proceed to question number 15. In question number 15, if the slab is inserted in capacitor C1, then now the dielectric has been inserted on this capacitor. That means here the capacitance has increased. It simply means the potential difference across this point must have increased. So I would say charge on C2 increased, charge on C3 increased. And on if these two systems, if the charge has increased, then definitely the charge must have increased on C1 also. Charge on C1 must have increased. So here charge on capacitor C1 increases is the correct answer. Charged on capacitor C1 decreases is wrong one. Charge on capacitor C2 increases and charge on capacitor C3 increases. So we are getting option A, C and D as the correct answer for question number 15. Now let's proceed to question number 16.